All right, now here in engineering graphics here at SAM, we're going to finish the hand drawing and we're going to go into AutoCAD, which is computer aided drafting or design. Auto, yeah, I know, it's not really automatic. It's more automatic than drawn by hand, but you still have to understand a couple of things. The key thing to remember in working with AutoCAD is you have to tell it, first, what do you want it to do? A line, a square, a circle, whatever. Then you have to tell it where do you want it to start, and then you have to give it specific information about the size it needs to be. Now here's a couple of things that you have to understand when you're working in AutoCAD. AutoCAD is still based on the old school DOS system, and it still goes back to coordinate systems. So even though with the dynamic input tool that they came out with about, I don't know, I'm going to say 8 years ago now, you still need to know your coordinate systems in case you're looking for a specific spot to start from. So you need to kind of understand those kind of things. Now, there's absolute, which is X and your Y. Think of that as, a lot of my students think of this one, best way to describe it is like you're playing checkers or you're playing chess. And this is your X and the Y. So your X is always going to be going horizontally, your Y will always be vertical. And if you'll notice here, Y, positive Y is up, negative Y is down, positive Y, X to the right, negative X to the left, and 0, 0. So just kind of think of that. Typically when we're drawing, if we're drawing like in graph paper, we assume that the bottom left-hand corner down here is your 0, 0, and then we're going to draw the coordinate stuff in here. You don't have to use this coordinate system, but you need to understand this coordinate system. So you need to know that if you see the X, comma, Y, that's what it represents. It's an absolute coordinate system. Now, how do you draw using it? You literally plot your point. So if this one is 9, 15, then this one stays on the 9, on the X, up, and it's 23, and then 12, 23, and so forth. So that's how your X and your Y, it's point to point to point to point. Then you have your relative. They're relative to the last position. They still use X and Y, but it's relative to the last spot you were at. So if you wanted it to go, let's say, up 5 squares, 6 squares, 7 squares, you do the at symbol because you're telling the computer, you're telling AutoCAD, I want you to go at, and then you say 0. So you're telling it, do not move in any direction, way, shape, or form on the X axis. But you want it to go up on the 5. And if you wanted it to go down, you would say negative. That's how that one works. If you wanted it to go to the left instead of the right, you would say at negative 5, comma 0. So that's how the relative works. It's kind of like a combination of the absolute system, but in reference to the last point. So think of it very similar. Yeah. So if you want to go up 2 squares, you're moving on the x-plane, 0, comma 2. If you want to go left, it would be 0 at negative 2. If you want it to go to the right, it would be at 2, comma 0. If you want it to go up and over 2, it would be at 2, comma 2. Does that make sense? So you just kind of have to think about those different things that we're dealing with. So there are some examples there showing you how you would draw a relative coordinate system. See, like I said right here, from this point here, it comes down 1, 2, and it goes to left 2. That's where that comes in from. Same thing from this point, it's going to go to the left 2, but it's going to go up 2. So therefore, you have to pay attention to your positive and your negative. So if you're using the relative system, make sure you understand that. And then we have your polar coordinate systems, which is very similar to your azimuth bearing that you're dealing with when you start doing some other things with your 0, 90, etc. So think of it, it's very similar. So you get 0, 90, 180, 270. The only difference is when we're doing azimuth bearing, this is 0, 90, 180, 270. So they're similar, but they're different. Kind of, I have students that have done both. They get a little confused. Just make sure you know what system you're working with. If you're working in AutoCAD, you're going to use polar. If you're working by hand and you're reading things, you're going to do the azimuth bearing, compass bearing. All right, so let's look here. So straight to the right is 0, straight up is 90, straight to the left is 180, straight down is 270. And then everything in between adds to it. So if I wanted to come this direction, instead of it being 45, it becomes 135, and that's where that comes from. And you have to remember about the polar coordinates is they're always going to be distance and angle. So it's always going to have that at sign at the beginning, just telling the computer that you want it to go from this last point. That's what the at stands for. At the last point, you need to go x distance, 2 squares at 45. Or 2 squares at 15 degrees, whatever it is, or 2 inches at that. Just remember the polar coordinate systems. Now, you can use any of these systems. If you're one of those people that you do best by plotting out your coordinates and typing and writing them in, great. You can use whichever method works for you. You can use the dynamic input. Just realize that there are multiple systems for this and make sure you're using the one that works best for you. If you're trying to use one of these 3 systems and you're working in AutoCAD, you need to hit the F12 key on your keyboard and turn dynamic input off, because if dynamic input is on, it will not work properly with these different system methods of inputting your coordinates, okay? And then, oh sorry, here's an example of how to use the polar. So if I'm starting here, I'm going to tell it, using my absolute coordinates, start at 25, 13. And then I'm going to say, okay, I want you to go up 2 squares at 282 at an angle 135. I get this quite often. Why is it 2.82? Because of the Pythagorean theory. A squared plus b squared equals c squared. So if you take 2 times 2, which is 4, 4 plus 4 is 8, you take the square root of 8, you get 2.82. It's some simple math, stuff you have to remember. So just think about that kind of stuff if you're doing that. If you're using the polar coordinates, remember, you've got to think of basic math and follow those Pythagorean theories. So there's some really basic, simple, straightforward reasons behind it. Again, reminder of why you use the 2.82, the 1.14. And again, what you're going to do is you're going to go through and you're going to draw your initials, and you're going to pick whatever coordinate systems you want to use. I really don't care. All I care about is, does your hand drawing match what you draw in AutoCAD? Okay, so you will give me your hand drawing, and you will staple your AutoCAD drawing, and you will staple them together and turn them in for me. And you'll also submit the AutoCAD drawing to me in Blackboard so that I can open it and check. But literally, that's what I'm looking for. I'm looking to see that you understand the basic coordinate systems, and you're able to apply whichever method works for you. Doesn't matter to me which one, or a combination of them, so that they match each other. That's all I'm looking for. All right, take your time, and you can totally do this. I know you can. You've got this.